Welcome back everyone to Learning by Teaching. We're in Statics and we're gonna do problem 6.2, okay? It says determine the force in each member of the truss and state if the members are in tension or compression. Set P1 equal to 45 kilonewtons and P2 equal to 30 kilonewtons. Okay, so we got this structure here that is P at A and B, and it's a 4 truss member. Okay, so the first thing that we need to know is that we're going to apply the method of joints. The method of joints is a method in which we're gonna pick one of these joints, for example C, D, B, or A, and we're gonna start we're going to do a little free body diagram of them and see if we can solve for the forces that these members are doing. But before doing all this, we're going to do a free body diagram of this guy. So let's do that free body diagram. Okay, so we got our truss member. And what forces do we have? Well, we got P2 that is going to the right. And P2, we're told that is 30 kilonewtons. Then we got P1, that is 45 kilonewtons. Okay, now at point B, since this is a pin, we'll have a reaction going to the right, so we're gonna call it Bx. Okay, let me put the name over here. We're gonna call it Bx, and we're gonna have a Y reaction called By. Same thing happens on A, we'll have Ax and Ay. Okay, now how do we start doing the method of joints? So which joint should we pick? So the key part of the method of joints is that we gotta pick the joint that has the less unknowns. Now, if we check in our case, the method with less unknowns is joint C. Why that one? Because we will have the force P1 that is going down, that we know how much it is. Then we'll have the force CV and we don't know, and also the force CD that we don't know. Okay, so we're gonna start with joint C. So joint C. Okay, and what we're gonna do, as I told you before, is that we're gonna do a small free body diagram of like my joint C. What forces do we have? We got P1 going down, which is 45 kilonewtons. Then we got force CV, and then we got force CD going. The direction of these two forces are assumed. Now, when you draw the joint and the forces are going away from the joint, we're assuming that the force is in tension. So for my problems, I always like to assume my forces are in tension. Now, if I get that the final result that my force is negative, that means that it should be going into the other direction, which means it's compression. Now that we have the free body diagram, let's start by we start doing the forces, equilibrium forces. So we start with the summatory of forces in the x direction. That should be equal to 0. Okay, what do we have? In here, we only got force CV. Therefore, my force CV should be equal to 0. Then, we can do the summatory of forces in the y direction. They should be equal to 0. And what do I have? Well, I got 45 kilonewtons going down, so I got negative 45 kilonewtons minus my force CD. And this should be equal to 0. If we solve for my force CD, we'll figure out that my force CD is equal to negative 45 kilonewtons. Okay? So as I explained before, if I get that my force is negative, that means that this member is in compression. So let's see. We figure it out. My member CV, so this one is done, and my force CD, my member force CD, so CD is done. in order to just finish with our 4 members, we need to do DV and DA. So the best joint to do now will be joint D, okay? So let's separate our work over here, and we're going to do joint D, okay? So we draw our joint. And which forces do we have? Well, we got P2 going to the right. We got P2. Then, let's just put the number in since we know it, which is 30 kilonewtons. Okay. Then we got our force CD. So my force CD. Then we will have my force DA. And lastly, we'll have our force DV. Diagonal up. Force DV. Okay. Now, what is this angle, or how can we relate this? So, if we take a look at here, we'll figure out that this is a similar triangle. This 1.5 and 2 meter. It's a similar triangle. Then it's not equal, but it's similar to my 3, 4, 5 triangle. Okay. So with that, we can say that this is a 3, 4, 5 triangle direction, and we can start doing our summatory of forces. So we start with my summatory of forces in the y direction because I only got 2 forces acting on the y direction. So I got my so let's just do that. Summatory of forces in the y direction, this should be equal to 0. Okay, so my FCD is going up plus 3/5 of my force DV going up, and all this should be equal to 0. Okay, so let's solve for my force DV, and my force DV should be equal to what? Negative FCD, so negative FCD, my force CD, multiply by 5/3. Okay, now we know the value of FCD, which is negative 45. So we got negative times negative, that gives me a positive number. Okay, so let me circle back from this, and we're gonna take our calculator. We're gonna take 45 multiplied by 5 divided by 3, and that will give me 75 kilonewtons. So we'll put it over here, 75 kilonewtons. And we got our answer positive. That means that my force DV is in tension. Okay? Now, let's do the summatory of forces in the x direction. This should be equal to 0. And what do we have? Then we got 30 kilonewtons going to the right. So we got positive 30. We got plus FDA. Then we got plus 4/5 of my force dV. Let's be consistent. dV. And all this should be equal to 0. Okay? So if we solve for my force FDA, so we got force VA should be equal to negative 30 minus 4/5 of my 75 kilonewtons. This 75 comes from our answer. And what is this equal to? So we're gonna go on the calculator, we're gonna go negative 30 minus 4/5 of my 75 kilonewtons. That gives me negative 90 kilonewtons. Okay? So if we were to write our answers, at the end we got force CV equal to 0. So we should write my force, let me write from here, CV equal to 0. Then we got my force CD equal to negative 45 kilonewtons. So what we're gonna do is that we're gonna write 45 kilonewtons in compression. So for compression, I'm going to write it with a Z inside of a parenthesis. Then we found out that my force dV is equal to 75 kilonewtons. And since we found that it's positive, we're going to put it as in tension. So we're going to have a T for tension. And last, my force dA, which is 90 kilonewtons in compression. Force dA equal to 90 kilonewtons in compression. Okay? Now, over here in this 2, I forgot my units, so I'm just going to put it over here at the end. But they should be like this one. Okay? Thank you guys for watching the video. I hope it was helpful, and I'll see you guys in the next one.